Welcome to my class Physics Untold. Here I am representing one of the interesting question from Pathfinder for Olympiad and JEE Advanced Physics from Newton's laws of motion, and this is MCQ number 1. So let's start this question. The question is a bead is a bead is released from one end of a frictionless rigid wire frame fixed in a vertical plane, slides periodically on the frame. Size of the bead is negligible as compared to the radius of the curvature of the turns, which is negligible as compared to the length of the straight portion of the frame. If the linear dimensions of the frame are made 4 times, by what factor will the frequency of the periodic motion of the bead change? So described thing in our question, or our the described things in our question is there is a wire frame whose some portion is inclined, next portion is a straight segment, and or horizontal segment, next is again a inclined segment. So let us consider this is our segment A, or this is our point 1, this is our point 2, this is our point 3, this is our point 4. These are the different points on the trajectory of the bead. Now as we are seeing that the acceleration due to gravity is acting everywhere in its motion. So for first segment, or for this is the length of the segment 1 to 2, that is equal to L again. So this segment 1 to 2 and segment 3 to 4 are both equally identical, so this must be equal to L, and let the horizontal segment, the length of the horizontal segment is equal to D. Now the acceleration due to gravity is acting vertically downward, so here G is also acting, but in the horizontal segment here G is also acting. But if we take, let the inclined segment is making some angle theta with the inclination, then therefore we can resolve the G into components. So the component of acceleration due to gravity along the inclination must be equal to, this must be equal to G cos theta. So acceleration component along the inclined plane or inclined wire segment is equal to G cos theta. This is the acceleration, and but here G is acting for the horizontal segment, the G is acting vertically downward, so there is no contribution of the acceleration in its pathway during the horizontal motion. So here acceleration A equal to 0. Again, here the acceleration is in this direction, that is G cos theta. Now for describing the concept behind this problem, the concept behind this question is, we can easily solve the problem by using proportionality concept. For proportionality constant, or for proportional change in dimensions, proportional change in dimension, let the dimensions, the old dimension is x, next dimension may be x, that is original size, it may be 2x, that is double, it may be 4x, that is 4 times, it may be 0.5x, or it may be half, and so on. And in this case we can solve the problem, this type of problem, easily by using proportionality concept. So for applying or using the proportionality concept, first of all we have to decide in which segment what type of motion it is. So for motion in the segment 1 to 2 or 3 to 4 segment, these two are identical. Here acceleration is acting, and here the length covered is equal to L, or therefore, and also acceleration is present, whose which acceleration is given as equal to g cos theta. Therefore, the total distance, for finding the total distance covered, we can use the kinematic equation. By using the kinematic equation, we can write the distance covered L equal to ut plus half a t square. Now we can again substitute the value of a, and initially the initial velocity is equal to 0. Therefore, we can write the L equal to half into value of a equal to g cos theta, value of a equal to g cos theta into t square. Or let this is our segment A, this is our segment B, this is our segment C. So for segment A, let this time taken is equal to TA, or we can say this L is proportional to TA square, and the same thing. And for let this is our equation number 1, and the same thing will happen for the segment. Same thing will be happen or repeat. This situation will repeat for the segment 3 to 4 or for the portion C. And again for the straight line segment, that is for motion for B or motion in the segment during 2 to 3. In this segment, the motion is uniform motion. Let the time taken here is equal to TV. So we can use the kinematic equations. If we use the kinematic equation, then we can write the equation v square equal to u square plus 2a into L. Now this, if you take the initial velocity as 0, therefore we can say this v square is proportional to L, or we can say this v is again proportional to root L. So this is happening during the segment 1 to 2, 2 to 3, or for the segment B. So the total time can be considered as the total time taken during its motion. The total time taken, let this total time equal to t, which is equal to 2 times ta plus 2 times ta plus tv, or this time will taken if the particle starts from here 1.1 and it reaches up to the 0.4, and after that motion stops. Or if it is repeated, the motion is repeated periodically, or after achieving or reaching the point number 4, it is further coming to the point number 3, further coming to the point number 2 and 1, or the reverse motion is occurred, then in that case the total time taken can be taken as t equal to, that should be equal to 4 times ta plus 2 times tb. Now whatever may be, in the first case we can say the length, the time is ta is proportional to what? The ta is proportional to root L. And in the second segment, the time taken tb, that's in second segment, the time taken tb is equal to the distance. Let here the distance is equal to d, this distance equal to L, this distance is again L. So here the distance covered is equal to d divided by its velocity, uniform velocity v. Now again we are seeing that in the segment, for the segment 2 to 3, this velocity is proportional to L, or we can say this tb equal to or proportional to, we can write this tb is proportional to d divided by root L. Now as for finding the total time taken, as we are seeing, the equation appears in the form t is equal to 4ta plus 2tv, or t equal to 2ta plus tb, etc. Here this 1, 2, 4 all are the constant of proportionality. So we can generalize this situation. If we generalize this situation, then for generalizing this situation we can take the total time taken t as equal to, as here is the constant 2 for one directional motion. For two directional motion, here constant is equal to 4. Here the constant is 1. For reverse motion also, including, the constant is equal to 2. So this 1, 2, 4 all are constant. Let this constant is a generalized constant c1. So we can say here this constant equal to c1 into ta plus the again next constant, that is c2 into tb. Again we are knowing that this ta is proportional to root l, this ta is proportional to root l, and tb, which is proportional to d divided by root l. Or we can write the equation in the form t equal to, let this is c1 dot, this is our c2 dot. So you can write this total time taken as equal to, as there is a proportionality sign, so we can, for coming from proportionality to, for removing the proportionality sign or making it equality, then we can change this c1 dot to c, or you can say this equal to c into the value of ta, which is proportional to root l, plus the second constant is now becoming, as there is a changing in proportionality, therefore let the new constant is equal to c2, and this tb is proportional to nothing but t divided by root l. Now in our mentioned question, l is both the dimension. It is mentioned in our question that if the linear dimension, it is mentioned in our question that if the linear dimensions of the frame are made 4 times. So now this t, this ld, this ld, l is now becoming 4l, and this d is again becoming 4d, because the total entire dimension is changing to the 4 times. Therefore we can replace the new time, let this new time equal to t dot, which is equal to c1 into the new length, which is equal to root 4l, plus c2 into this d equal to, now it is now becoming 4d, and this root l is now becoming root 4l. Or if you simplify this equation, then you can write this should be equal to 2 root equal to 2 c1 root l plus 2 c1 root l plus 2 c2 d divided by root l. Now again we can take this 2 as common. If we are taking 2 as common, then we can remove this 2 from here, and after removing, this is now, as from observation, we are seeing that this c1 into root l plus c2 into d divided by root l is nothing, this is nothing but equal to t. So this t dot, for as a nutshell, we can say this new time t dot, is now becoming equal to 2 times t. So if the new time becomes 2 times, so its frequency, as we know that frequency f equal to 1 divided by t, or frequency the reciprocal of the time period or time taken. So if, let its new old frequency equal to f and its new frequency is f dot, so f dot should be equal to 1 divided by t dot. So but this f dot, this t dot equal to, this t dot is nothing but 2t, so we can replace here t dot as 2t, or we can write this f dot equal to 1 divided by 2 into t, or we can simplify this equation as f dot equal to half into 1 divided by t, or 1. Now this 1 divided by t is, it is nothing but it is nothing but our frequency f. So we can conclude that the for this type of motion, if the for this type of motion, if the frequency, if the dimension of or size of the path is changing double, changing 4 times, then its period of frequency of the periodic motion, it's becoming half times. If it's if it is it will become, if the dimension changes to 9 times, or it is if the dimension increased to 9 times, then it will become 3 times. The frequency will be 1/3 new frequency. And it is if it will become if the new dimension will be equal to, let the new dimension is now becoming 1/4, then its frequency of motion of this type of periodic motion will be equal to double of its previous frequency. Hope all are all understood this question or this problem or this solution approach. Thanks for watching this solution or video. Like, share and subscribe for more videos like this. Thank you.